Okay, so despite what the topic is, this is not an assignment. It's just what the topic, this part of the topic is called. It's called assignments. Okay, so another possible problem in networks could be to determine the exact flows through each path in the network, so that as much of the capacity of each edge as possible is used. And with this type of problem, it's called an assignment or an allocation problem. Okay, for example, 3 generators for 5 towns. Each town receives its requirement regardless of which generator. So we don't necessarily need to know at this stage what we're trying to do, but we're trying to find what the exact flows might be. And to start this type of problem, we need to go through the concept of a bipartite graph. Okay, so copy that down. At this stage, it's not super critical, but copy that down. So a bipartite graph is a type of graph where the nodes can be separated into 2 types of nodes. One is the supply and one is the demand. Okay, so copy that and we'll look at an example. Okay, so we've got an example of 4 students in a class and the subjects they studied. So this is what the bipartite graph would look like. So that's this information. So the bipartite graph. So the supply is A, B, C, D. The demand, the subjects are biology, chemistry, physics, and psychology. And what we're doing, we're just going to join them up. So for instance, Alice does biology and she does chemistry. Betty does chemistry and physics. Carly does biology. She does chemistry and she does psychology, and Diane just does psychology. So that's what a bipartite graph looks like. Okay, so we're connecting them all up. Okay, straightforward. Okay, so now we move on to what's called the allocation problem, and this is consider a situation where there are a number of jobs to be done and the same number of people to do them. So each person can do each job in a different maybe amount of time, or it might be for a different cost. Okay, so we've had bipartite and now we're looking at allocation problems. Copy that, come across. Okay, so here's an example. Alan, Bob and Charles have three people and there's 3 jobs, job X, job Y, job Z, and they can only do one job each, and we've got to work out what's the quickest way of doing it. So for instance, how to read this table. So Alan and X is 10, so he would take 10 hours to do job X. Charles intersecting with job Y is an 8, so Charles would take 8 hours to do job Y. So that's how you read the table. So here on this page we'll look at the method on how to solve it. Okay, so job X, job Y. So I've just transferred the information. So the first thing is you find the smallest number in each row. So the smallest number is a 4, the smallest number is an 8, and the smallest number is a 7. So the first step is identify the smallest number in each row, and then we subtract that number from all the numbers in that row. So that would turn that into a 6, that into a 0, and that into a 5. That's a 0, that's a 3, that's a 2, that's a 2, that's a 1, and that's a 0. So that's what we've done there in step 1. Now the next step is cover all the zeros with the smallest number of straight lines not on a diagonal. So straight lines, vertical or horizontal. So like for instance, 1, 2, 3. Okay. If the number of lines equals the number of jobs, then we have the allocation. We could have done it vertically. So for instance, we'll change colours. And so we could have gone, I see the wrong colour, I'll change it to the colour. That way. So we could have done that way, and that way. So we've covered the zeros each way, and if the number of lines equal the number of jobs, then we have finished the problem. And so what the job allocation would be, so the people are A, B and C, and the jobs are X, Y and Z. So A will do job Y, B will do job X, and C will do job Z. And that's the allocation. So here's the bipartite graph. And we've done the allocation of work up there. Okay, and so the minimum amount of time would be, going back to the original numbers, it would be 4 plus 8 plus 7, so the minimum time would be 19 hours. And that's it. Okay, so there'll be some exercises to do. Bye.